Now we're ready for some word problems. Are you guys excited for some word problems? That is normally the response I get when I ask that question, right? People don't get excited for word problems. Although the irony is, word problems are probably more realistic in terms of how you might see math in the real world, right? Because you're never going to like walk around and just see a math equation like in the grocery store, right? But you might have to do math and figure out, okay, if I only have $20 in my pocket, you know, how many candy bars can I buy or something? So it actually does show up. So let's check out this one. You have a 36-inch board that will be cut into 3 pieces so that the second piece is 3 times as long as the first piece, and the third piece is 5 times as long as the first piece. If X represents the length of the first piece, find the lengths of all 3 pieces. Okay, so what I'm going to do that I think is really important is you always need to set up your expressions first before you jump to creating an equation. If you jump right to creating an equation, often you'll make a mistake with the equation. So this is why I always recommend, I'm going to write down here first piece, second piece, third piece, and we're going to come up with expressions for each of them involving X in some way, and then we'll create the equation. So I know it's an extra step, but it allows you to then most likely get the right answer. It also helps you at the end to figure out all of your answers. So the first piece they actually tell us is going to be X, right? It says that right in the problem. X is the length of the first piece. So X for the first piece. Then what does it say for the second piece? It says the second piece is 3 times as long. So how would you write 3 times as long as the first piece?
3x.
Good. And then it says the third piece is 5 times as long. So how would you write that?
5x.
Good. And then what you're doing is you're adding all 3 pieces together, and their total has to be what? What does it tell you in the problem?
36.
36 inches, right? So that's what we're going to do. So now we have our 3 expressions. We're going to add them together. X plus 3x plus 5x, and set it equal to 36. So any questions on how we set it up? Because sometimes for these problems, the hardest part is actually setting up, and the solving actually isn't too bad.
I'm pretty good. Like, I just remember yesterday in my quiz, I have a question like that. I spent like 8 to 10 minutes to figure out how to set it up, and I can't. Finally, I leave it like that. And after a couple of times, I remember what to do. So it's funny.
So you've got it now. Well, I think you froze. Okay. So now we combine like terms, right? X plus 3x plus 5x. What does that give us?
9x.
Good. Then we divide by 9, right? So x equals 4. Very good. Okay, now x happens to represent the length of the first piece, right? So that tells us that the length of the first piece is going to be 4, and all of these are going to be inches because we're just talking about length, so length is always inches. So these are all going to be inches. Okay, for the second piece, we have to do 3x or 3 times 4, right? So what is that going to give us?
12. Oh,
very good. Yep. And for the last piece, the third piece?
It's 5 times x.
So 5 times 4, which is?
20.
20. So 12 and 20. Now with word problems, by the way, it's really nice to check because it's not very difficult to check and see, does 4 plus 12 plus 20 equal 36, right? That isn't a rough calculation to do at all. So compared to some of the other problems where it would involve, adding and subtracting and multiplying and dividing with fractions or things, here it's not too bad to double check that your three numbers add up to 36. So sometimes word problems are easier to check than other problems. Okay, so let's try number 12. Use the table to find the value of x, then write a sentence to explain in words the meaning and the value of x. Okay. First thing I want to do is look at this part right here where it says 22,681 more than x. What operation does more than refer to? Adding, subtracting, multiplying, or dividing?
Adding.
Adding, good. So this would be the same as saying 22,681 plus x, right? But that's not all we have because we still have this x here, right? I'm just saying that that part is equal to that, right? So now they give us the total, and anytime you have a total, if you think of being at like a grocery store, when they give you the total, they added up all of the items, right? So here we're going to add up the 3D plus the non-3D screens and set it equal to the total, right? So x plus 22,681 plus x, right? Because this is the 3D, this is the non-3D, equals the total, which is 38,255. Okay, now we combine like terms, right? So x plus x gives us 2x. The nice thing about the word problems is the algebra isn't normally quite as complicated, right? So it's more involved to set up the equation, but solving it normally does not involve quite as many steps. Although this one involves some big numbers. But I think are you guys allowed to use like a basic calculator? I think so, right? So you don't have to do this on paper or anything. So you're going to subtract 22,681 from both sides. So let's work that out. 38,255 minus 22,681. Okay, I got 15,574. Did you guys get that?
Yes.
Okay. And then the last step?
Divide.
Good. So what answer do you get?
I got 7,787.
Perfect. So that is the answer for x. That would go here. And then when it says, what is the meaning of x? This is when you have to look back at your chart. X represents the what, according to the chart?
The 3D?
The 3D screens. Yep. So which one says that? A, B, C, or D?
Well, the value of x is the number of non-digit, the value of this total screen, the value, C.
C. Very good. Yep. Because X just represents the 3D screens. That's where X is. It falls in that row in that column. Very good. Okay, let's check out number 13. The flag of a country contains an isosceles triangle. Recall that an isosceles triangle contains two angles with the same measure. So that's going to be important here. Two of the angles are going to be the same. If the measure of the third angle is 20 degrees more than 3 times the measure of either of the other angles, find the measure of each angle of the triangle. Recall that the sum of the measures of the angles of a triangle is 180. So that was nice of them to remind you of that your sum or your total is going to be 180. So this is when, just like I did with the pieces of the wood at the top of the page, I'm going to write out an expression for the first angle, the second angle, and the third angle. So let's pretend the first two angles are the ones that are the same, right? So if the first angle we call X, what would you call the second angle if they're the same?
X.
It's also going to be X. Good. Then the third angle, it says, is 20 more than 3 times the measure of the other angles. So 20 more than 3 times X. So how would you write that?
20 plus 3x.
Very good.
Plus 2x.
Good. Are there any questions so far about how I came up with those expressions? No? Okay. Now we're going to add them up and set it equal to 180, right? Because the sum of the measures of the angles of any triangle is always 180. Okay, so why don't you guys try to solve it from here? See if you can find X and then plug back in X to figure out your angle measures. So what is X plus 3X? If we combine like terms here, what do you get?
5x.
Good. Then we can subtract 20 from both sides, right, to get the X by itself. So we get 5x equals 160. So X is going to equal
32.
Good. So that would be the first angle and the second angle, because they're both just X, are both going to be 32 degrees. And then for the third angle, we're going to do 20 plus 3 times 32. Three times 32 is 96, right? And then if you add 20 to that, what do you get?
116.
Good. Nice job. So let's move on to the next page. Okay, for this one, we're going to start out by filling in the table. So we're looking at consecutive integers. So if you have a number like 7, what's the integer that comes after 7?
8.
8. Good. And then how could you have gotten from 7 to 8? Technically, what did you add?
1.
1. Okay, good. So if you have an integer x, the next integer is going to be x plus 1. You take the original integer and add 1 to it. Now, if you add another 1, right, 1 plus 1, now your next integer is actually going to be x plus 2, right? Because if you go back to my example, 7, 8, the next number would be 9, right? To get from 7 to 9, you added 2. Okay, and then what would be the third one? What would you put here?
X plus 3.
X plus 3, good. So that's how you fill in the chart. Then they want you to find the sum of the second, third, and fourth consecutive integers. So they want you to add these integers together, not the original one for some reason. They're just asking you to add together the second, third, and fourth. So if you combine those like terms, you have x plus x plus x. What does that give us?
3x.
Good. And then 1 plus 2 plus 3.
Five.
Okay, so we're doing 1 plus 2 plus 3. I think you missed the 1.
6.
There you go. Perfect. So now we're going to apply that to a word problem. So number 15, to make an international phone call, you need the code for the country you're calling. The codes for countries A, B, and C are 3 consecutive integers whose sum is 102. So 3 consecutive integers. Okay, so we go off to the side a little bit here. So let's say the code for country A is X. If the code for country B is the next integer, the consecutive integer, how would you write it using X?
X plus 1.
Good. And then how would you write country C's code if it's the next integer after that?
X plus 2.
Good. Then it tells us that their sum is 102. So we're going to add those integers together, x plus 1 plus x plus 2 equals 102. Okay, so what is x plus x plus x?
3x.
And then 1 plus 2.
3.
Good. Then we want to get the 3x alone, so we're going to subtract 3 from both sides. So 3x is going to equal 99. So x is going to equal 33. So then how would you fill in the blanks? Country A's code is
33.
good. Country B,
34.
good. Add 1, good. And then country C,
35.
very good. And then you can always check if you add 33 plus 34 plus 35, do you get 102? And you do. So another one where it's not too bad to check the answer.